As you watch this ice skater glide across the ice, they are essentially moving their body from one location on the ice to another. It's not just about going from one spot to another, it's like they're performing a mathematical dance called a translation. Hey everyone, welcome back to our math series where today we're going to learn about this special movement called a translation. A translation is a movement or a slide of a figure without changing its size or shape. We can translate a figure in any direction and by any distance. Here we have triangle ABC on the coordinate plane. Each point, A, B, and C has its own coordinates or ordered pair. And remember, ordered pairs are written in the form of x comma y. Now let's say we want to translate or slide this triangle 4 units to the right and 3 units down. How do we do that? I think you're going to be very surprised at just how easy this is to do. There are 2 different methods that we can use. The first method is to use the coordinate plane or grid. Let's start at the top vertex with point B. We need to move 4 units to the right and then we need to move 3 units down. This new point is the image of point B, so we label it point B prime. The symbol to the right of the letter indicates that word prime that I used to describe it. Next, let's move point A. Again, we'll move 4 units right and 3 units down. And this new point is A prime. We have one more point to translate, point C. Moving 4 units right and 3 units down, we have our new point C, C prime. Next, we need to close up the triangle by connecting the vertices. And now we have the new image of our translated triangle, and we need to find the coordinates for each vertex. Let's start with A prime. I see the x-coordinate is positive 1 and the y-coordinate is negative 2. For point B prime, the x-coordinate is positive 3 and the y is positive 1. The last vertex at point C prime, the x is positive 2 and the y is negative 4. The second method uses the coordinates of the red triangle. Let's start with the ordered pair for point A, negative 3, positive 1. Since the triangle is translating 4 units to the right in the positive direction along the x-axis, we will add 4 to the x-coordinate. And we will subtract 3 from the y-coordinate because the triangle is moving 3 units down. Completing these 2 calculations will result in the ordered pair positive 1, negative 2 for point A prime in the new image. Point B in the figure has an ordered pair of negative 1, positive 4. We will again add 4 to the x-coordinate of negative 1 and subtract 3 from the y-coordinate of positive 4, resulting in the ordered pair for point B prime of positive 3, positive 1. We have one last vertex to go. Point C's coordinates are negative 2, negative 1. Adding 4 to the x-coordinate and subtracting 3 from the y-coordinate results in the translated ordered pair of positive 2, negative 4 for the new image. All we have left to do is close the image by connecting the vertices. Now let's look at a real-world scenario. Here we have a map of Lake George. There is a fishing boat and it has located a school of fish at point F on their fish finder, which uses sonar technology. As the boat is heading towards the fish translate or move to point D. We need to be able to describe this translation of the school of fish in order to find them on the map. So starting at point F, we need to move 5 units to the right and then move 1 unit up. Can the fishing boat make the same translation as the school of fish did? Well, let's see. Starting at point B, we'll move 5 units to the right and then 1 unit up. As we can see, the boat would not be able to make the same translation as the fish because it needs to stay in the water. So what kind of translation could the boat make to reach the school of fish at point D? Remember, the boat needs to stay in the water. Since there are many ways that the fishing boat can reach point D, I will need to choose the path for the purpose of this video. I'm going to start by moving 2 units to the right, then 4 units up. Since I've not reached point D yet, I need to keep translating. So I'll move another 2 units to the right to reach point D and catch some fish. Now it's your turn. Translate the red trapezoid 2 units left and 4 units down. What are the coordinates of the image? Choose one of the 2 methods I just showed you. Go ahead and pause now. Great, let's see how you did. If you use method 1, then starting at point A, move 2 units left and then 4 units down. This is the location of point A prime, negative 3, 0. Then make the same movements for point B, then for point C, and lastly point D. The last step is to close the image of the translated trapezoid. So the coordinates of the translated image of the red trapezoid are point A prime, negative 3, 0, point B prime, 0, negative 1, point C prime, positive 1, negative 4, and point D prime is negative 3, negative 5. If you use the second method, you would subtract 2 from each x-coordinate and subtract 4 from each y-coordinate. Starting with point A, we subtract 2 from negative 1 and subtract 4 from positive 4. This gives us the coordinate negative 3, 0 for point A prime. Then we'll do the same process for point B, then point C, and finish up with point D. The last step is to close the figure, and we're done. Thanks for joining me today, and be sure to click on one of these two videos next for more awesome math.